Hello everyone, welcome back to my YouTube channel. Myself Nidhi from Sri Venkateshwara College of Engineering, Bangalore. My USN number is 1V23CD032. I'm from the third sem student, the Department of Data Science. The course code is BCS303 and operating system is the course title. So in this video, let us discuss about. So in this session, we will be understanding about the deadlocks in the operating system, causes, sequence, and the solution for that. Let us see the introduction of the deadlock, where it defines in an operating system, it occurs when a group of processes becomes stuck in such a way that none of them can proceed because each process will be waiting for a resource that is held by another process in a group. This situation prevents the system from progressing or completing the task. So in this scenario, we can see a deadlock. This presentation will explore the causes, consequences, and some possible solution for the deadlock situation. In a multi-programming environment, a deadlock it can also be said where a set of processes are blocked because each process is holded by a resource and waiting for another resource held by another processor. Understanding this is crucial for the system stability we will be seeing ahead. So let us see some of the causes of deadlock, where deadlock can be arise from circular wait, hold and wait, resource contention, and no preemption conditions. Identifying these causes is essential for preventing the deadlocks and the system design and operation. So basically, this resource contention it occurs when multiple process or thread complete for limited system resources such as CPU time, memory, disk spaces, or the I/O devices. This contention can lead to perform degradation, inefficiency, or even deadlocks if not managed properly. Understanding how resources are allocated and managed in this to avoid contention and ensure smooth operations. We will see. Let us see the second cause, which is circular wait, which occurs when a set of processes are waiting for each other in a circular chain. This condition is major contributor for the deadlock and must be managed efficiently to prevent the system stalls. Hold and wait. In this hold and wait condition, the process hold on a resource while waiting for the others. This behavior can lead to deadlocks if not carefully controlled, making it necessary to implement strategies. Also, it describes a situation where a process is holding at least one resource and waiting for additional resources that are currently held by other processes. This condition can lead to the resource contention as we've seen before and contribute for the deadlock. The non-preemption condition states that the resource cannot be forcibly taken from any of the process which is holded. So this can lead to deadlocks if processes are waiting for resources held by others. The process must release the resources voluntarily after the completion of its task. Some of the key characteristics of non-preemption are a process can only release its held resources when it is ready or completed with its operation. If a process is waiting for additional resources, it continues to hold its current resources, leading to potential resource contention or the deadlock. Let us see some of the consequences of the deadlock, where in an operating system, it can range from minor performance degradation to survive the system instability, depending on how the deadlock is managed. So let us see some of the primary consequences. System halt or freeze. When processes are deadlocked, they cannot proceed, where these causes the system to stop responding or freezes. If critical processes are involved, the system may need a reboot to recover. Resource wastage, where the resource held by the deadlock process remains unavailable even though they are not being used effectively. This reduces overall system throughput and the efficiencies, performance degradation, process starvation, data corruption, reduced system reliability, increased administrative costs, loss of business of productivity. So these are some of the consequences of deadlocks. How are the deadlocks detected? So in an operating system, it involves identifying situation where the deadlocks have occurred so that the system can take corrective action to recover it. It is one of the strategies of handling the deadlocks, often used when the deadlock prevention or the avoidance is not profitable. System model, where the resources like memory, files, CPU are categorized into types with each multiple instances. Data structure, where the allocation of the matrix is available vectors, request matrix, these are all taken care. Reduction algorithm, the system which checks for the cycle and the resource allocation graph, the detection cycle. So these are all used for detecting the deadlocks. Deadlock prevention. The strategy focuses on ensuring that at least one of the necessary conditions for the deadlock cannot hold. The techniques which includes the resource allocation strategies and carefully scheduling of process execution, which helps in prevention. Recovery strategies such as process termination or resource preemption, these are employed where these methods help in restoring the system functionality but may also involve the trade OS. Let us see the conclusion of this video where understanding the deadlocks and operating system is crucial for maintaining system stability and performances. By recognizing the causes, accessing the consequences, and implementing the effective solution, we can also avoid the risk of associated deadlocks. Thank you for watching the video. Do like, share, and subscribe.